video will be covering the practice test, which has questions involving vectors, basics of motion, kinematics, and 2 questions on free fall for the honors class. So let's take a look. Start with number 1. Which is a vector quantity? So let's start with a definition for vectors. What is a vector? It should be a physical quantity with both magnitude and direction. And if we look at our choices, we could cross off A, B, and C. That leaves us with D, velocity. V for vector for velocity. All right, number 2, a student walks 3 blocks south, 4 blocks west, and 3 blocks north. What is the displacement of the student? So if we draw this out, 3 south, 4 west, 3 north, the 2 north and south cross out, and you're left with 4 west. Number 3 is a similar type of question. Draw it out. And you should get 2 blocks east. Number 4, you have a vector pointing up and to the left, so you need to pick the pair of vectors that best represents the 2 concurrent forces that combine to produce the resultant force vector. If you draw the resultant vector for each choice, the one that best fits it is choice D. It's not exactly up and to the right, but it's the closest one. Number 5 is a similar idea. This is a little easier, choice D. Number 6, vector components. All right. So horizontal is X, vertical is Y. If you know SOHCAHTOA, you should know that sine goes with Y and cosine goes with X. So if we write our formula out for the horizontal component, 24 newtons is our vector times the cosine of our angle, 35 degrees. That should give us about 20 newtons. And if you do the calculation for the vertical component, 24 newtons times the sine of 35 degrees, this time you should get 14 newtons. Now we're up on number 7, same idea. This time we're looking just for the vertical component of the initial velocity. AY is equal to A sine theta. We plug and chug. A, our vector, is 25 meters per second. Our angle is 53 degrees. Multiply the 2, 25 times sine of 53 degrees. And you should get 20 meters per second. Number 8 is similar to the earlier questions. Girl leaves the classroom, walks 10 meters north, then walks 30 meters south, up 10, down 30. You should get a displacement of 20 south. Number 9, which pair of graphs represents the same motion? This can be tricky. So the thing is to just write out the motion of each motion graph. And if you look at choice A, both already show positive acceleration. So that is our answer, but it doesn't hurt to look at the others. By the way, I've taken a different approach to making these videos. I just did the video beforehand, and now I'm doing the audio recording. My voice was a little raspy earlier, a few days ago. How are your weekends, by the way, everyone? Hope you're not studying too hard. Okay, number 10. So we got to calculate the total distance of the car traveled during the time interval of 4 seconds to 8 seconds. So here we're looking for the shaded area under the graph. And this only happens for a speed versus time graph. So let's mark up our sections, 4 to 8 seconds, shade in the region, and you should get this weird shape. And so you should divide it up into a triangle and a rectangle as best as you can. And it should be around the 5 meters per second mark that you can divide it up. So when you take the area of the triangle, 1/2 base times height, 1/2 times 4 seconds times 5 meters per second should get us 10 meters. And then the rectangle section, base times height, 4 seconds times 5 meters per second, and that gets us 20 meters. Last thing, you gotta add them up and you get 30 meters total. Number 11 follows the same idea, this time all for the first 6 seconds, from 0 to 6 seconds. So you should have a triangle from 0 to 2 seconds and a square for 2 to 6 seconds. So find the area of both shapes. While past me is working out the math, guess what I did this weekend? I've been watching figure skating. The season has started again. It's my favorite sport to watch during the winter. Fun fact, next week I'll be going to Toronto to watch a figure skating event. It's got all the top-notch figure skaters in the world. Well, not all of them. Just a good amount of them. And 50 meters is our answer for number 11. Number 12, the speedometer in a car does not measure the car's velocity because velocity is what? So let's think about it. A speedometer measures speed, and that's a scalar. So vector must be for velocity. It's choice A. Number 13 is simple average speed of the car using a motion graph. You have a distance versus time graph, so the slope of this represents the speed. Just find a slope, 2 points, calculate slope, and you should get 2 meters per second. 14 is same idea, this time with just numbers instead of a graph. 3.6 meters in 1.8 seconds. V is equal to d over t. 3.6 meters over 1.8 seconds, and that should get us also 2 meters per second. There are a lot of questions that are just like this, and I expect every single one of you to get this right. Okay, number 15. As time increases, the speed of the car, what? All right, so this graph didn't even come with axis labels. So I looked at my answer key, and it turned out it was actually a displacement versus time graph. And so on a distance versus time graph, the speed of the cart is represented by the slope. And as it steadily increases, the speed remains the same. It's a constant velocity on this type of a graph. But if it were a velocity versus time graph, what would we say about the speed of the cart? Then it would increase over time. Number 16 is a throwback to number 9. So we got to figure out which pair of graphs represent the same motion. If we look at choice A, we see a rest and positive acceleration, not choice A. Choice B, we have a positive deceleration with a positive constant velocity. That's not correct either. Choice C, positive acceleration and a positive acceleration. Yay! That's our answer. But let's look at choice D anyway. It's a negative velocity with a positive acceleration. Not correct. Number 17. Runner completed the 100-meter dash in 10 seconds. Her average speed was, wow, a female running that fast. I don't think that's been done before. 10 meters per second. What's the fastest record for women? running the 100-meter dash. I'm not sure, but I don't think they ever touched the 10-second barrier, if I ever recall. Number 18. Okay. Plug and chug, simple. Number 19. Speed versus time graph, total distance, 4 seconds. We have a triangle as our shape. Area equals 1/2 base times height, 1/2 times 4 seconds times 20 meters per second. That should get you 40 meters. 20. High-speed train in Japan travels a distance of 300 kilometers in 3.6 times 10 to the third seconds. I gave this question in class before. We gotta figure out the speed. So notice our units and the choices are meters per second, but we gave our distance in kilometers. So we gotta change that to meters. 300 kilometers is 300,000 meters over 3,600 seconds. And you should get 83.3 meters per second as your answer. Number 21, a student on her way to school walks 4 blocks east, 3 blocks north, and another 4 blocks east. I gave you this question too in class. All right, compared to the distance she walks, the magnitude of her displacement from home to school is... So if you calculate the distance, it's the travel path. 4 plus 3 plus 4 equals 11 blocks. Displacement is the straight line in blue. You can make a triangle for Pythagorean theorem to solve it. 8 squared plus 3 squared equals 64 plus 9, and that should give you 73. So you take the square root of 73 to get your displacement. That's about 8.5-ish, between 8 or 9. And so from that number, you could see that the displacement is less than the distance. And this is always the case. The displacement can either be equal or less than the distance. Number 22, a golf ball is propelled with an initial velocity of 60 meters per second at 37 degrees above the horizontal. We got to find the horizontal component, so AX is equal to A cosine theta. Or you can use your SOHCAHTOA method if you want. 60 meters per second times cosine of 37 degrees, and that should get you 47.9 meters per second, approximately choice D. 23. Plug and chug acceleration formula. Acceleration is equal to change in velocity over time. Starts from rest, so our initial velocity is 0 meters per second. Final velocity is 8 meters per second, and our time is 4 seconds. And the answer is 2 meters per second squared. 24, a student walks 40 meters along a hallway that heads due north, then turns and walks 30 meters along another hallway that heads due east. Magnitude of the student's resultant displacement. 40 north, 30 east. That's a Pythagorean triple, so you should get our resultant to be 50 meters. Number 25. 20 Newton force due north and a 40 Newton force due east act concurrently. So when we say concurrently, it means at the same time. So we gotta figure out the magnitude of the resultant force, use Pythagorean theorem. Should always make a habit of showing units in your work like I'm doing here. You don't have to show units in the intermediate math steps, but just when you substitute and your answer. You should get approximately 45 newtons. 26, we finally reach a kinematics question. How far? So for these types of questions, I highly recommend writing your variables on the side. We don't have a distance. We got initial velocity of 15 meters per second, a deceleration rate of -7 meters per second squared, to a full stop, so that means our final velocity is 0 meters per second. We don't know time, but we don't need to know that for this problem. We can solve for distance with the following formula: vf squared equals vi squared plus 2ad. Then you would just plug your values in like such. Do not forget units. And that negative sign as well for that acceleration number. Solve for d. So for this intermediate math step, as I'm showing right here, you don't have to show units. So 225 divided by 14 should get you d, and d is equal to 16 meters. Number 27, how long will it take an object to move 100 meters if the object is traveling with an average speed of 0.5 meters per second? So we don't have an acceleration at all, so we can use our constant velocity formula. V is equal to d over t. I'm going to start referring to this as constant velocity formula. Plug and chug, you should get that t is equal to 200 seconds. A car initially traveling east with a speed of 5 meters per second is accelerated uniformly at 2 meters per second squared for 10 seconds along a straight line. And during this time interval, we got to figure out the total distance. This is another kinematics problem. This time we have a time, we got initial velocity and acceleration when we're looking for d. So you can use that kinematic equation. D is equal to VIT plus 1/2 AT squared. Then you plug and chug. While I'm working out the math, I'll tell you that I'm excited to watch Ice Dance today on NBC. And the men's free skate. You should tune into NBC later this afternoon so you can watch some figure skating and tell me who your favorite skaters are. If you don't like figure skating, well, I guess that's you. And number 28, the answer is 60 meters. Number 29 and 30 are the free fall questions for the honors class. So here, we're dealing with motion in the vertical direction. So our magnitude of acceleration is 9.81 meters per second squared only on Earth. That number is just for Earth. But when you go to another planet, that number is going to be different. And that's what 29 is asking for. We're on a different planet, so we got to figure out a different acceleration due to gravity based on the values given. A rock falls from rest. The vertical distance of 0.72 meters to the surface of the planet in 0.63 seconds. You get our initial velocity is 0 meters per second. If you're dropping it, distance is 0.72 meters and time is 0.63 seconds. We're looking for A. So you can use the formula like in 28. D is equal to VIT plus 1/2 AT squared. So you just plug and chug. You get acceleration due to gravity on this strange planet to be 3.6 meters per second squared, choice C. Number 30. This time we're back on Earth, so our acceleration is 9.81 meters per second squared. Once again, our initial velocity is 0 meters per second. Speed of the object, we're looking for VF, and the distance it's fallen is 4.9 meters. So we can use VF squared equals VI squared plus 2AD. You plug and chug. And you should get that VF is 9.8 meters per second. Excellent. And that's it.